Welcome to an exploration of particle physics, the fascinating study of the fundamental building blocks of the universe. In this series, we'll journey into the heart of matter itself, discovering the smallest constituents that make up everything around us. Particle physics helps us understand the very nature of reality at its most basic level. Particle physics is the study of the smallest constituents of matter and the forces that govern their interactions. It explores the fundamental nature of reality by examining particles that are far smaller than atoms. These tiny particles and the forces between them determine how everything in the universe behaves, from the structure of atoms to the workings of stars. The Standard Model is the theoretical framework that describes all known elementary particles and their interactions. It's one of the greatest achievements in modern physics, organizing fundamental particles into three main categories: quarks, leptons, and force carriers. This model successfully explains how particles interact through three of the four fundamental forces in nature. Quarks are the fundamental particles that combine to form protons and neutrons. There are 6 types, or flavors, of quarks, organized into 3 generations. The first generation includes up and down quarks, which make up ordinary matter. The second generation contains charm and strange quarks, while the third generation has top and bottom quarks. Each generation is heavier than the previous one. Quarks have several unique properties that set them apart. They carry fractional electric charges, either plus 2/3 or minus 1/3. Each quark also has a color charge, which can be red, green, or blue. Quarks are never found in isolation due to a phenomenon called confinement. Instead, they always combine with other quarks to form composite particles called hadrons, such as protons and neutrons. Leptons are another family of fundamental particles. Unlike quarks, leptons do not carry color charge and therefore don't experience the strong nuclear force. There are 6 leptons organized into 3 generations. The charged leptons are the electron, muon, and tau. Each has an associated neutrino: the electron neutrino, muon neutrino, and tau neutrino. The electron is the lightest and most familiar lepton. Leptons have distinct properties that distinguish them from quarks. Charged leptons carry an electric charge of -1, while neutrinos are electrically neutral. Unlike quarks, leptons have no color charge and don't interact through the strong nuclear force. Leptons can exist as free particles in isolation. Their masses increase with each generation, with the electron being the lightest and the tau being the heaviest. Force carriers, also called bosons, are particles that mediate the fundamental forces between matter particles. The photon carries the electromagnetic force, allowing charged particles to interact. Gluons mediate the strong nuclear force, binding quarks together. W and Z bosons carry the weak nuclear force, responsible for certain types of radioactive decay. The Higgs boson is special. It doesn't carry a force, but instead gives other particles their mass. The universe is governed by 4 fundamental forces. The strong force binds quarks together inside protons and neutrons. The electromagnetic force acts between charged particles and is responsible for electricity and magnetism. The weak force is responsible for radioactive decay and certain nuclear reactions. Gravity, the 4th force, is familiar from everyday experience, but is not yet integrated into the Standard Model of particle physics. Matter particles are organized into 3 generations of increasing mass. The first generation includes up and down quarks, electrons, and electron neutrinos. This generation makes up all ordinary matter around us. The second generation contains charm and strange quarks, muons, and muon neutrinos. The third generation has top and bottom quarks, taus, and tau neutrinos. Particles in higher generations are heavier and less stable, quickly decaying into first-generation particles.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.